Students, we are going to start the lecture number 3 in this course on materials informatics. So, in the last 2 lectures I gave you some idea, or rather I would say basic idea about what is the material informatics is about, and what is this difference between material informatics and the machine learning and deep learning courses. So, first we are just focusing on initial concepts or introductory concepts. So, I am going to move into today on statistics and regression, and that is the first machine learning model which I am going to discuss in detail, so that you can understand the basics aspects of regression. And idea will be to give you perspectives so that you can understand and apply it. So, couple of example I gave you in the last 2 lectures. One is the energy efficient clean. I discussed a lot about that. Prior to this, I discussed about something about the structural applications on using different kinds of objects, but I want to spend a little bit time on this because I missed out something in the last lecture. As you know, the idea was to design a clean which is energetically efficient. And so, clean is basically a oven, and we raise the temperature of the oven by heating up. Either you can heat by using electrical energy, or you can heat by using the burning the fossil fuels. But nowadays, because of the concern of environmental pollutions, we use normally electrical heaters to heat the temperatures of these ovens to about 1000 degrees Celsius temperatures. And if you want to minimize the energy consumptions, 2 things we have to understand. One, the heat loss to the walls of these clean. A heat loss can happen because of thermal conduction, and we know that conduction is basically governed by the the Fourier's law, and so therefore, we can write down conductive heat is like this: lambda del T by del x in one dimensional case, while lambda is the thermal conductivity, and this can be written as a lambda Ti minus T naught. T naught is outer temperature, Ti is the inside temperature, divided by W is the thickness. This is the heat loss because of the heat getting conducted away through the walls of the container. So, you can reduce the Q value by making the wall thicker. W, if you increase W to higher value, the Q1 will be reduced. You can also reduce the heat loss simply by changing the lambda, right? Lambda is the thermal conductivity. That means, by changing the material, you can reduce the Q, and also you can reduce the Q by increasing the W. Am I clear? There is another aspects of heat loss which can happen. See, here increase the temperature of the oven. So, heat will be absorbed by the inside walls of the oven, right? And that absorbing ability of the material is decided by the Cp, or the specific heat capacity. So, heat absorbed, it is absorbed, not absorbed. Remember the difference between absorption and absorption is different. Heat absorbed by inner walls, that is Q2, and Q2 can be written simply as what? Cp density thickness into multiplied by Ti minus T naught by T. Let me check whether the thickness will go to the upside or downside, that I must check. I think it will go to downside, right? That is what will happen. That will be lambda by 2. Am I clear? So, where is it? Yeah. So, this is going to be okay, and this will be obviously T, time will be there, correct. The total heat depends on time. So, now if you can clearly see, if we increase, oh sorry, again I have done a mistake, this W will go up. As you can see here that if you increase the W here, Q will increase, right. But here if you increase the first case, equation 1, if you increase the W, Q1 will decrease. But second equation, if you increase W, Q2 will increase. So, therefore, W or thickness has different roles to play depending on the whether you are considering Q1 and Q2. How to minimize the effect of W? You want to do that, first what we can do, we can take the first equation and take a differentiation of that with respect to W, then it's become minus lambda Ti minus T naught into T divided by W square. Am I clear? So, now we can actually take same thing also for Q2, this will be Cp rho Ti minus T naught divided by 2. So, by simply putting both of them equal to 0 or rather making both of them equal to same, we can get W is basically equal to what? You will get W will be equal to something like T1 T will go cancel 2 of lambda by rho Cp to the power half into temperature time. So, that means it becomes 2 A to the power half T to the power half. So, A is the thermal diffusivity, which is nothing but lambda by rho Cp. So, therefore, simply by minimizing A, I can minimize W. That is my first important aspects of the discussion. Simply by minimizing A, I can minimize the W. Time is obviously depends on how much time you can give it for heating. So, this is the first important aspect, and if you want to minimize A, you need to minimize lambda, maximize Cp and maximize rho. So, these are the two important aspects you learn from these small calculations. So, in case of choice of materials, we have to choose material which can minimize lambda, thermal conductivity, maximize Cp, which is heat capacity, and also maximize the rho. So, that is what is our line, this is what we can think about it, the index, and this is the plot between thermal conductivity versus thermal diffusivity you can see here, and this along this line you can see the materials which will be above this line, they will satisfy that. So, obviously, you cannot use metals which has very high lambda, we should use thermal conductivity which is quite low, something less than 1. Similarly, thermal diffusivity should be between 10 to the minus 6 and minus 7 meters per second. So, it brings us these materials. First is the brick. Brick is the most widely used material because it is a low M value, and so the thickness should be 90, you can calculate that. Concrete you can use also, it is high temperature material, this can both can withstand high temperature applications, and you can use also woods, elastomer, but they can be used only at lower temperatures. So, 1000 degrees Celsius temperature, these two are the choices of material which you can use. This is something actually I missed out in the last class, so I thought I should discuss with you. Well, in the last illustration or illustration number 3, we talked about processing requirements of forming a fan in a vacuum cleaner or a computer or a laptop. I discussed about it and I talked about it that we need to use only thermoplastic material. So, therefore, we can use mostly blow molding or compression molding kind of techniques for this purposes. So, I had introduced in material informatics, I will not discuss much about this, let me go directly into the class what we talked about in the last lecture, and yeah. So, in lecture number 3 we talked about, when we talk about very important aspect, that is what is called the machine learning approaches. So, in case of machine learning approaches, as you understand, machine learning is what? It is basically computer program, right, and computer program which is told to learn from experience, but experience with respect to certain task. You cannot talk about any task and get experience, right. We can have specific task, and like to give an example, where as I gave you in the last lecture, when you were at the young age or as a kid, you try to learn how to walk on the floor. So, your task was to walk on the floor, and when you do that you may fall, you may sit back, fall. So, this is what is your learning. So, you learn by doing mistakes, And so therefore, a computer program learns simply from experience, and experience comes in terms of data. Data is nothing but a set of records, right. Each record provides you certain description of the instance or what is known as a sample, right. Suppose you are measuring temperature of a furnace as a function of time. So, T is its time and temperature is given by capital Ti. So, at each instance of time, so T1, T2, T3, T4, T5, these are the temperatures. This is what is your data or data sets. Now, in this data sets, each instance is called, or each measurement is called the instance or the sample. So, this is your data set. Here each in time scale, that means suppose let us say this is T1 and at time T1, small t1, this is one instance. So, this is my data which I have collected from my experience, and this is what is used for kind of learning the things. Okay. And components like time and temperature, they are called as features, or very important aspects is that. So, in the ideal case, we would like to find the relationship between time and temperature, right, when you are heating a furnace up. And then what we can do, once you know the relationship, then we can find out for any new time what will be the temperature. So, that is what actually machine learning does. Machine learning basically try to figure out the relationship between the variable and the what is called the resultant. So, here T time is your variable and temperature is your resultant value. So, do we need to find out the relationship between these two in such a way that we can always predict the temperature at any given time. So, that is what is the machine learning does. Machine learning approach basically handles that way. So, basic premises of such a kind of relationship is basically the data. If you have data, then only you can actually find out the relationships. Now, to find a relationship, you can use different kinds of models, statistical models, simple models, complex models, all kinds of models you can use, but you always start with a very simple model. That is what is called regression, which we will discuss in today's lecture. So, first of all, when you do that, what you are trying to do? We are trying to make the machine learn, but at the same time prediction capability has to improve. You learn something, but after learning your prediction capability get decreased. That is not the machine learning approach is. Machine learning approach tells you once you learn, once the machine learns from the data for a specific task with a. So, therefore, once it is learned, the evolution of the task what you have been doing is measured in terms of performance. Performance must improve as the machine learns and more. So, what I mean to say very simple, once you start walking on the floor as a young kid, initially you will like to learn very slowly, so that you do not fall off. Sometime you like to hold on some something on the room, maybe a table or chair, so that you do not fall off, right. But as the time goes on, you learn from more experiences and then you can walk on your own. That means in the process your efficiency of doing the job or task is improving, and efficiency is measured in terms of performance, what is called P. So, for a given task, the machine learns from experience or data and deliver the prediction capability, whatever we talk about it, delivered with a higher performance. Then only you call this as a machine learning. So, in a machine learning process, there are three important aspects. One is called task, second is called experience, and third is called performance. Task means a particular job, right. Experience means the data, what kind of data available with you. If you have good quality data, experience is good. So, good quality or bad quality depends on various aspects, we will talk about later. But let us consider everything is good quality data. So, experience comes from the data. So, and third aspect is the performance. That is why in a machine learning model there are three things: experience, task, performance. Am I clear? So, we simply gather data from various sources, then I do a lot of data preprocessing, or what is called as a data engineering or feature engineering, and after that we can actually develop a model. And this model basically based on is selected machine learning algorithms, and after the model is applied, we find out whether the model is doing good job, its efficiency is higher, performance is better or not. That we can calculate from errors, because every model will predict something, but the process will make some errors. So, we have to estimate the errors in the process. So, then we compare the errors incurred when you use different kinds of models, and that is what we can decide. Finally, one can actually do data visualization also, plot it and see that also. So, this is in a nutshell what the machine learning process looks like. So, if you have to talk about the workflow, first is data. Either you can get data from experiments or calculations or simulations, you can even generate data also. Once you do that data, then you have to do data preprocessing and data engineering. You may have some missing data, you may have some data which are not following certain trends, outlier data. So, you have to do something with the data, we can talk about little later. That is a very important aspect of data preprocessing. And finally, once the data are preprocessed, you feed the data with a model. That is what we discussed today at the later part of the class, the first model. And then after the model is fitted, model has to be validated in terms of compare the model data or predicted data with the actual experimental data or calculated data. So, that then you can calculate the error, right, difference between these two. One is the actual calculated data or experimental data and the model predicted data. If these two are widely different, the error is large, then your model is not going good. So, therefore, these are the 5 steps: data generation or data collections, data engineering, model training, testing, model validation and deployment. These are the 5 different steps of machine learning. So, what is the meaning of training? Training means you give the data to the machine, it learns from the machine, correct, and in that process it can basically learn by using some supervision or without supervision. So, that means training can be done by supervision or without supervision. Like if you are walking on the floor as a young kid, your parents may help you, that is what is called supervision learning, right. And if your friends are not helping you, making you believe that you can do yourself, then it is called unsupervised learning, that you are learning on your own, right. So, there are different types of learning possible, and then the model actually learns. Once the model is learned, then you can test the model actually using the new data. So, therefore, in a training process, we simply iterate the model tendency and develop that. So, these two are the main procedures. One is called training, other one is called testing. How do you know your model is working or not? So, once you train, sorry, there is a mistake here, let me correct it. Once you train, then you have to test it, right. So, training is basically done to fit a model. These two are connected to each other. So, as I said, there are 2 types of models, 2 types of learning basically. One is called supervised learning, and is called unsupervised learning. In the supervised learning, what do? You have a data in such way that you have both the input variable as well as the output. That means you have both input and output data, just like one I gave you, time versus temperature. Okay. This is what is called the input and output. So, time is your input, temperature is your output. So, one can simply say this is independent variable, this is dependent variable. One can say this is independent variable, this is level. There are many kinds of terminologies used, correct, or you can say response and the independent variables. So, mostly in the statistics we call independent variables, independent variable, and we always write as x, right, and dependent variable. And dependent variable is its y. You can always talk independent variable as variable This is also told as response. You can always talk this as a label. Okay. There are different kinds of terminologies used. So, in case of supervised learning, you have both the data available with you, both the input variable as well as output variables. So, therefore, you can always easy to develop predictive model. The regression is one such predictive model, classification is another such predictive models. But you know, there were situations where you may not have both the data available with you. You have one set of data. Let us talk about image. You are talking about image. In image, you have basically what you have. We have a image. It has the pictures. Pictures are nothing but a pixels, right? So you have only input data. In that case, what you can do? You can do unsupervised learning. Like clustering is one such unsupervised learning. Let us talk about cholera outbreak in your city, correct? There are certain pockets of a city has cholera, major cholera outbreak, or you know, typhoid outbreaks, and now you want to plot it in your map. So what do you have? You have only input variables, the locations of the places where cholera outbreak or you know malaria outbreak or whatever outbreak has happened. So that's then you can actually find out the regions where these places where this outbreak has happened. You can talk about clusters of data, right? That's what is called unsupervised learning. So group the data and interpret the data based on only input. That's the key aspects you to understand that. So these are the two major learning methods we use in case of machine learning or deep learning. And you know, we material science use both actually. Majority of our models are basically supervised learning, but there are some models which were use unsupervised learning. Supervised learning requires supervision, that is training data, and they are accompanied by labels. I already talked about what is label, and then you can actually do this training and testing. Unsupervised learning, you have only one set of data. That means you have input data, your label data unknown. So that's what then we can actually do clustering or some kind of modeling. So there are two important class of models which we will discuss for supervised learning. One is called regression, other one is called classification. In today's lecture, we will talk about regression mostly. Okay. So let me go back into that process, regression. Okay. So for regression is what? What is regression? What do you think? This is the most simple model to use, and it is considered the statistical analysis of the statistical analysis procedure. It's basically nothing but a statistical analysis procedure. What you do in the statistical analysis procedure? We simply try to estimate quantitative relationship. Remember this. This is a very important word. We try to estimate quantitative relationship between what and what? Between independent variable and response or dependent variable, correct? That means we try to find out quantitative relationship between x and y. This is what we try to find out, where y is a function of x. So this relationship is found out from the data, correct? So that is the main aspects of regression. This is a statistical analysis procedure in which we try to estimate the quantitative relationship between independent variable and the response. So here independent variable is x, your dependent variable or response is y. We need to find out relationship between these two. So once you have a good relationship between these two, we can predict the value of y for a new value of x. That's the machine learning job does. Machine learning wants to predict the value of y for a new value of x. So first you have to train the model with the given data, so that you can understand the relationships. Once the relationships are known, then simply for any known value, unknown value, so any new value of x, very easy to find out the value of y. So this is the main aspects of regression. You try to understand that. Okay. So it basically allows you to find the relationship between these two. This regression analysis allows you to find this relationship. Remember that. That is what this analysis is about. So, let me take an example from the material science, that will be good. All of you know that diffusivity D is a relationship between like this. This is better, right? Diffusivity is a function of temperature, correct? So, we can write down this expression very simple. If I take a log on both sides, am I clear? So, now if I have data, let us say I have data between D and temperature. I have this kind of data with me, lot of such data experimentally determined, and I want to fit this. So, very simple, I can write an equation y is equal to W 0 plus W x, where y is log of dt, okay, and x is 1 by t. So, W 0 is intercept of a straight line equation, right, intercept, you can clearly see that, and W is basically slope. Am I clear? This is very easily can be found out. So, your task will be to find out the value of W 0 and W. Once you know these two coefficients, the relationship between y and x is known, and for any new value of x, you can predict the value of y. That is in a nutshell is regression analysis is. So, let us stop here, we will come back to the next part of the lecture and discuss in a detailed manner. Thank you.